Welcome to the video lecture of Comparative Design. This video presents a part B of SLR parser which discusses the SLR parsing algorithm. This slide explains the model of an LR parser. The basic model of an LR parser consists of stack, input buffer, then output, then a parsing table, and LR parsing algorithm is a program that make the input and stack work together along with the parsing table to produce the output. This LR parsing table has two parts, action part and go-to part. In action part, the rows correspond to the states and columns correspond to terminal as well as dollar symbol. Whereas in go-to part, the rows correspond to state and columns correspond to non-terminal of the grammar. Basically, these are two parts, but it can be combined into a single table. A single table with the two parts, action part and go-to part. So when we observe the stack, the bottom stack symbol is S0, and after that there is a grammar symbol x1, after that there is a state, like that it can be continued. Then the input contain the input string with a dollar at its right end. Then after LR parsing, it will produce the output. Output means the productions. It will output the production. Since LR parser is a bottom-up parser, we expect the output to be the productions which can build a parse tree starting from the leaves moving towards the root. The configuration of LR parsing algorithm can be explained with the configuration of stack as well as the input buffer. Here the stack contents are stored here, S0, X1, S1, like that, alternate positions, state symbol and grammar symbol. Then the input buffer, that is shown by AI to AN, and it is appended with a dollar at its right end. So this SM and AI decides the parser action by consulting the parsing action table. That means based on the state and based on the current input symbol, based on the state means based on the current stack top, and based on the input symbol currently pointed, we have to observe the parsing table and we have to perform the LR parsing. This slide shows the parsing table. This parsing table has two parts, action part and go-to part. This is the action table, this is the go-to table. These are the states, how we can identify how many states will be there for a parsing table, that we can understand from the next slides. And these are the columns. Under action part, it will carry the terminals as well as dollar symbol. So from here from IT to till dollar, that is the action part. This non-terminals as the columns will form the go-to part. These are the productions we are going to consider. That is, we are going to consider a string that is built from this set of productions for doing this SLR parsing. The actions of LR parser are shift, reduce, accept and error. Since basically LR parser is a shift reduce parser, here the shift is indicated by shift S, and reduce is indicated by reduce. Along with that reduce, there will be a production. Third action is accept, fourth action is error. Coming to the first action, shift S, it indicates that we have to shift the next input symbol and the state S onto the stack. It can be explained with the help of this general statement, that is, currently the stack top is having the symbol SM on the stack, and input pointer is pointing to AI. Then on seeing a shift S, we have to perform a shift action. That is, we have to shift this input symbol AI onto the stack. So now AI is on the stack, and in addition to that, we have to shift the state denoted by S also onto the stack top. Second action is reduce. Reduce by the given production. A gives beta. A is the left hand side of the production, which is a non-terminal. Beta is the right hand side of the production. It can be a combination of grammar symbol. That means it can be a terminal, it can be a non-terminal, or it can be a combination of terminal or non-terminal. Here, on seeing a reduce action, we have to pop 2 times the number of symbols on the right hand side of the given production from the stack top initially. That is clear from this generalized denotation. That is, currently SM is on the stack top, AI is the input symbol pointed by the input pointer. If the action is reduced by a particular production, we have to pop 2 times the number of symbols on the right hand side. Here we are assuming it as R. So we have to pop R symbol from the stack top. So now the stack top is having SM minus R and XM minus R. Then we have to examine the go to part of SM minus R. But before that, we have to push the left hand side of the production, that is capital A, onto the stack. So now the stack top is having capital A. So next step, we have to observe the go to part of the parsing table corresponding to SM minus R and A. There we can see a state. That state also is required to be pushed onto the stack top. Then after performing the reduce action, we have to output that particular production. Then third action is accept. We can announce a successful parsing in case of seeing an accept action, which is indicated in parsing table as ACC. If we come across an empty entry in the action table of a parsing of a parser, it will be an error. So that will be encountered as an error. This is the LR parsing algorithm. The previous slide explained the actions, and that same thing is represented as an algorithm. Input will be a string, and it will be appended with a dollar at the right hand side, and output for a parser, we are expecting the output as productions. So we have to initially point the first symbol. We have to point the first symbol of W dollar. Then we have to push the initial state S0 onto the stack. Then we have to perform the actions, shift, then reduce. Then if the action table is having an accept action, then announce successful parsing. Otherwise, if we come across an empty entry, announce it as error. So this is a slide that shows the LR parsing algorithm, illustration of LR parsing algorithm. For that, we will be given initially a string. That is, here we are considering as an example ID star ID plus ID. That is the string, and appending that string with a dollar at the right end. And the productions, this string came from the production, set of production. E gives E plus T, E gives T, T gives T star F, T gives F gives E within bracket, F gives ID. So as the basic model of an LR parser indicates, there will be an input buffer which is holding an input string with a dollar at the right end, and there will be an output to indicate the set of productions that is required to construct the parse tree. Then there will be a stack, and there will be a parsing table which has 2 parts, action part and go to part. So this stack, initially we have to push the initial state onto the stack. The initial state is 0, that will be pushed onto the stack. Then the parsing algorithm says that we have to observe the current stack top and the current input symbol. So here the current stack top is 0 and current input is ID. So we have to identify what is the action recorded inside 0 under ID. The state 0 and ID, the action is S5. S indicates shift. 5 indicates the state symbol. Shift 5. So on seeing a shift action, we have to shift ID onto the stack as well as this 5 onto the stack. So the action we have to write it as shift 5. So now ID and 5 is on the stack top. Then again current stack top is 5. Currently the input pointer is pointing to star. So what is the next thing? We have to observe what is 5 under star. 5 under star is R6. That means it indicates that reduce using the 6th production. 6th production is F gives ID. The one thing you have to remember is that the production has to be numbered, sequentially numbered. Here the 6th production is F gives ID. So if the reduce is the action, we have to observe the production. We have to observe the right hand side of the production, count the number of symbols on the right hand side. Here F gives ID, the number of symbols on the right hand side is ID is considered as a single symbol, so 1. So double the number of symbols, that is 2 into 1, that is 2. 2 symbols are to be popped from the stack. So 5 is to be popped, ID is to be popped from the stack. And as a next step, we have to push the left hand side of the production, that is here, it is the F onto the stack top. Now 0 and F are the contents of the stack top. The stack top is having F and the entry just below the stack top is 0. So we have to examine the go to part of 0 under F. 0 under F, it is 3. So that 3 also to be pushed onto the stack. So we have to write the action in the previous step as reduce by F gives ID and output as with the production we have used, that is F gives ID. Then examine the stack top, it is 3 and input pointer is pointing to star. 3 under star it is R4. That is again a reduce action, reduce using the 4th production T gives F. T gives F means F is on the right hand side of the production. F means single symbol, so the double the single symbol means 2 symbols are to be popped from the stack. That means 3 and F is to be popped from the stack. Then we have to push the left hand side of the production T onto the stack. So now T is pushed onto the stack. Then in addition to that, we have to observe the go to part, that is 0 under T. What is 0 under T? That is 2. 2 is to be pushed onto the stack. Then currently the 2 is on the stack top and input point is pointing to star. What is 2 under star? It is S7. That indicates shift 7. That means we have to shift the current input, that is star, onto the stack as well as this state 7 onto the stack. Then we have to continue by observing the stack top and input pointer, that is here 7 under ID. What is 7 under ID? It is S5. It is a shift action, so ID is to be shifted, 5 is to be shifted, then 5 under plus, again 5 under plus, it is reduced using the production R6. Therefore right hand side is having only single symbol, pop 2 times the single symbol, that is 2 symbols are to be popped from the stack. Then we have to push the left hand side F onto the stack, then observe the go to part of 7 under F. 7 under F, the go to part is 10, so we have to push that 10 onto the stack. Similarly, we have to continue for till we get a accept action, that is 9 under $. While we proceed like this, we can see 9 under $, that is reduced by E gives E plus T, that is reduced using the production R1. Here the number of symbols on the right hand side is 3. 3 into 2, 6 symbols is to be popped from the stack. 1, 2, 3, 4, 5, 6. The 6 symbols are to be popped from the stack and we have to push the left hand side, that is E, onto the stack. Now 0 under E, 0 under E, the action is 1. 0 under E, the entry is 1. So we have to push N1 onto the stack. Then we have to currently examine what is the stack top. 1 under $. It is pointed by $100, it is accept, ACC, it denotes the accept. So we can announce a successful parsing. So this parsing action is to be continued. Either you get into an empty entry or you are getting into an accept entry in the parsing table.